Hello everyone, let's solve another math problem. Prove the statement using the precise definition of a limit. We'll take the limit as x approaches 0 of the cube root of x is equal to 0. Okay, so the precise definition of the limit, what they're talking about here is the delta-epsilon version of the definition of a limit. So I'll write out the sort of logical statement that we need to prove here. Okay, so for the version of the question we're given here with the specific function, the cube root of x, the specific value of x given 0, and we're told the limit already is 0. I mean, this should be obvious to anyone who's even if you just plot this function. We need to show the following. So what I'm going to do is maybe not say fix, I'll say suppose epsilon greater than 0 is given. Okay, and now I will say let delta be equal to epsilon cubed. Okay, then x less than delta means that the absolute value of x is less than epsilon cubed. And if I now take a cube root of both sides, I get that the cube root of the absolute value of x is less than epsilon. I mean, we know epsilon's a positive number, so when taking a cube root, we're just going to take the positive value. And a positive value. I guess cube roots of positives are always positives. We're ignoring complex numbers here completely. Okay, and then what can I do here? The cube root of the absolute value of x is equal to the absolute value of the cube root of x. Right? You can work out all the possible cases for yourself. If x is positive, then these two things are clearly equal. If x is negative, well, we make it positive, then take the cube root. That's the same thing as taking the cube root and then making the result positive. And you'll see that this is exactly the series of implications that we wanted. So what we have here is if we're given any value of epsilon, I can choose my value of delta, and the way I'm going to choose it is by making it equal to epsilon cubed. So for any epsilon greater than 0, there exists a delta greater than 0. And if x, the absolute value of x is less than delta, going through this logic tells us that the absolute value of the cube root of x is less than epsilon, which is what we wanted to show here. And so we're done. This type of delta epsilon version of a limit, in this case, it was quite easy because, if you know, it was easy, I suppose, for one, the main reason is because we were evaluating the limit at 0. And so there's kind of like a direct relationship that I knew I'd be able to choose between epsilon and delta here. If we were proving this limit rigorously to any other value of x, it might be a little bit more complicated. But because of the shape of the cube root function, this choice would still work, but proving that it works might take a little bit more effort. Yeah, I'm not going to say too much more about this question, I guess, but if I find some kind of mistake, or if I do have more comments to add, I'll put them down in the description. Thanks for watching.